Hey guys, good morning. We are in the 12th session of Oracle 12c Core DBA course. Sorry, 19th session of Oracle 12c Core DBA course. And we are in the 12th chapter, which deals with performance tuning basics. And why am I saying or referring to performance tuning basics is it is just a introduction to the terminologies, introduction to what an Oracle DBA will look for when it comes to performance tuning. So that is what we are going to cover in this chapter number 12. I'm hoping that this chapter would take two sessions at least. So session number 19 and session number 20 would basically concentrate on performance tuning basics. So before we actually start, let us do a quick recap of whatever we have covered so far, and then we will begin with performance tuning activities. Okay. So we in the 11 chapters that we have covered so far, the first chapter was installation of Oracle database, and to begin with, we divided this complete course into two parts, right? So non-CDB architecture is first, and then we will pick up the CDB architecture. So we are still in the non-CDB architecture part, and in which we started the installation of Oracle database and non-CDB architecture, in which we have done the software installations, we have set up the VMware, we have installed the Oracle database software, and then we have also understood the prerequisites on the Linux. We have also understood, what are the details of each and every action that we perform on Linux for setting up the Oracle database. And then we have completed the software installation as well as the database installation in chapter number 1. Then we have went into the chapter number 2 with the actual architecture of Oracle database, which is again non-CDB, with which we have first of all divided the architecture into three components. One is, Oracle has divided into two parts. One is instance and one is database. Instance is made of process architecture and memory architecture. So what we did is, in the chapter number 2, we started with memory architecture. So memory architecture we covered completely, that is called as SGA. Okay, so that is what we covered in chapter number 2, system global area, all the different components and their purposes. Then chapter number 3 we covered the next part of the architecture, that is process architecture. So process architecture is like an intermediate between, it connects instance memory components to storage architectures. So that is the main purpose of your, process architecture. We call them background processes, also PGA. So all the system processes will also be part of this process architecture. So that's what we did in, chapter number 3, and then chapter number 4 covered the third part of the architecture, that is storage. So we have clearly differentiated how does your data will be persistent in the database. So the persistent data in the Oracle database is in the storage, that is nothing but disks, and how does your memory background processes will start communicating with the storage architectures is what we covered in chapter number 4. Then chapter number 5 is what the configuration of your Oracle database. So as you know that we can change the size of the instance, we can change, number of processes that connects to the database server, we can change the locations of the control files, etc., etc. All that can be configurable. So all those configurable values of your Oracle databases, we call them as parameters or initialization parameters. Why it is called initialization parameters? These parameters are used while initializing your database. That means while your database is coming up. So that's why the name is given as initialization parameters. And then we have seen the two different files from which the parameters can be picked up by the Oracle database, that is SP file, P file, and we have also seen how to set them. Okay, that was chapter number 5. And chapter number 6 we have understood what are the different stages of starting up the instance and bringing down the instance, so that you guys can choose whatever is the mode of startup that you guys need according to the activity that you perform. That was chapter number 6. And chapter number 7 we covered the complete network configurations related to the Oracle database. That means if a application server wants to connect to the Oracle database, how does it do, and how do you basically run a continuous service on the Oracle server to actually accept the connections from the uh, application server. So that is nothing but the listener configurations and TNS configurations. And application, how are the different ways, what are the different ways available for the application server to connect to the Oracle database is what we covered in chapter number 7. And then chapter number 8 spoke about managing the data architectures, data structures. Those are nothing but the table spaces. Managing includes creating, viewing, deleting, moving, etc. So all those things we basically understood in chapter number 8. And we have also covered few of the in-depth concepts also, like OMF, non-OMF, ASM, okay, all of them. And we have also listed down the list of activities which are majorly done by the DBAs, but it needs a lot of basic understanding of the complete database architecture. So that's the reason those activities are took forward to the next course, so we will deal that later. And then administering users, definitely this is one of the important sections, because when application wants to connect to the Oracle database, he need to have a user available created and also password, and the permissions on the Oracle database should also be limited. So we understood what are the different ways to create a user, give him a password, give him a privileges, a specific privileges in the form of roles, like system privileges, object privileges, etc. All that we have basically discussed a lot in chapter number 9. And then chapter number 10, we dealt with the undo data. So undo is as equivalent to control Z when you're working on your Microsoft Word or any other tool. So undo is nothing but bringing back your old data after you do the changes currently. So how does that specific undo works in Oracle database is what we covered in chapter number 10. And what are the table spaces available, and also what is temporary undo is what we spoke about, which is new in 12c. Then the last chapter that we covered was on data concurrency. That is nothing but how Oracle manages multiple transactions at a single moment. That is nothing but if multiple users are trying to change the data value of a same row, how does Oracle handles it is what we covered in chapter number 11. So quickly we are in the chapter number 12 now. So in the performance tuning management, that is what we are going to deal with. And as you would see, this particular chapter I have come up with 13 topics. Probably we will deal with 7 topics, that is until waits, in the current session, and then the rest of the topics will be taken forward to the next session. And before we start with, yes, VMware is what we will have to begin with. So let me bring up our server and then we will start the discussion. And consider that this particular chapter would be a little bit of dry. So saying dry in the sense you will be having most of the concepts than the real time showcase. So this is the reason why I wanted you guys to be patient and also have some patience. And the reason is, though this is dry, you will lose a bit of interest to follow. But if you are losing the if you are not following it, it is going to trouble you a lot when you are progressing in your Oracle DBA profile, because most toughest job for an Oracle DBA is to work on performance issues. So the reason why it has become tough is there are a lot of dry concepts around performance tuning. If you are not understanding all those dry concepts, you will feel trouble to act upon the performance tuning. That's it. That is the only job. So what I'm trying to tell you is, try to follow each and everything whatever we are discussing today. That becomes the base for your performance tuning skill set in the future. Okay, so it will be a little bit of dry, but I'll try to make it as easy as possible for you guys to understand and remember. Though we will not be able to cover A to Z in the performance tuning, it's a basics. So we pick up the very important basic points and then we will be very strong in it. That is more than sufficient for any DBA profile in the market. So the topics has been designed in such way. Okay, so now let us begin with the terminologies first. So let us go to this. And this is one of the most commonly seen image whenever you see and performance tuning by DBA that he does. There is one of the blog also deals about what are the list of activities that we as a DBA will do. So I think my blog name was why do I love being an Oracle DBA. That particular blog will tell you most of this image. Okay, so as an Oracle DBA, you basically have to handle memory allocation issues. Okay, so how is your Oracle database utilizing memory, and why is it using high memory, why is it using low memory, or is there any memory leakages, any memory contentions? All that has to be taken care by DBA. So having said that, you have to have the knowledge on how does Linux or Unix operating systems mostly deal with memory components. And then resource contentions. So resource contentions would include CPU and also memory. So most of them, CPU is what I consider that as resource. So in case if your database is not able to utilize CPU, or in case if your database is not receiving enough CPU to process the request, so that is what we call it as a contention. And then how do you deal with those contentions is also the headache of your Oracle DBA. Now, having said that, the next part is input output. So that is nothing but I/O. Mostly people will not refer input output; they will directly say I/O. That means whenever you want to read a data from the disk, there is an I/O operation performed. That means input operation and output operation. So when the Oracle database deals with I/Os, in case if there is any delay on the disk side or on the memory side or on the CPU side, there would be a I/O effect. So in case if there is a delay in I/O, definitely the end user will see the performance issue. They will see that there is a lot of delay in getting up the data. So even such I/O issues will also come forward to DBAs to handle. So that means, having said that, DBA should also have the knowledge on how disk level I/O operations will happen. Okay, so that is said. Now comes to application code problems, because the application code development is not done by one developer. It would be hundreds of developers developing an application, right? One application that uses our database. So there is a possibility that each developer will write the code in his own style, and and developers of different experience levels will also include in the application development. So it is often agreed the fact that application code, most of the times application code will not be as optimum as expected, just because of diversity in experiences, diversity in the way that they code. So that is the reason one of the most important problems that DBS will face is to handle the application team, guys. So to phase out or to come up with a statement saying that this is an application SQL problem, it needs a tuning, etc., etc., we struggle a lot to prove that. So to understand that one, you need application understanding as well. And then the network, yes, definitely your database server will be on a different Linux machine and your application will be on a different Linux machine. So whenever there is a data flow between application server and the database server, if there are any network level bottlenecks as well, because if the network is common across all the servers, if a database server is ready to push 100 packets of data, but because of the network bandwidth it can only push 10 packets of data per second, that means definitely there is a network issue, right? If network is able to accept 100 packets per second, definitely the database would be much better than 10 packets per second. So this is how the network bottlenecks would also be one of the performance tuning areas that Oracle DBA would be working on. All right. So all these terminology is most of the time memories, CPUs, IOs, and then application code. All of them are most oftenly heard as an Oracle DBA. Okay, you have to be well prepared to handle all of this. So your basics of computer architecture will help us a lot here. So in case if you remember the CPU architecture that you have studied when you have learned the computers for the first time, you have a central processing unit, you have your RAM, that is random access memory, and then whenever a process is given to the system, it goes to the complete data is kept into the random access memory, and then each and every process is picked by the CPU and then it processes it, and then the intermediate data or the result data is basically again kept back in the RAM, that is your random access memory. And there are clocks in, clock in, clock out. There is a frequency of your CPU frequency is also very, very important for better performance. All of that you have learnt in your childhood will be very, very important. It will help you to understand the architecture of your Oracle database. That will be the key actually. Okay, and frankly speaking, I have forgot after I have learnt in my childhood about all these system architectures and all. But once I started my DBA profile, I had to get back to my slate, and then I had to revise and see how exactly a system works whenever there is a process given to the CPU, and that's the reason why I still remember. So I really ask you guys to do that, because it is common, all the softwares will run on a system. So in case if you know that inner architecture, right, you will have a better confidence handling softwares which uses those hardware components. Okay. So yeah, now coming to a bit of much more terminologies that are very close to the DBAs. So these are the three activities that every DBA will face in real time. So one is performance planning. Mostly architects will do it. Okay, so that means 10 plus years. Guys who deal with architecting the Oracle database will do this performance planning. So I often do this for new projects. I often do this for the databases which are, under very huge performance issues. So if the database is not able to handle any of the performance, it is not performing as expected, we will have to re-architect the Oracle database so that it can handle the request smoothly. So even then, I think performance planning will come there. And then instance tuning. This is what a mid-level and instance tuning and SQL tuning is most oftenly handled by mid-level Oracle DBA experts. So when I say mid-level Oracle DBA experts, 3 to 8 years, right? So 3 to 8 years experience guys will basically handle these instance and SQL level tunings, right? So it doesn't mean that even 8 plus guys will not do it. They will do it in case if they face it, but mostly these activities are handled by 3 to 8 years of experience guys. And now let us go a bit of explanation of all these terminologies first before we go in detail of each and every activities. Okay, that is what we are going to do in first 7 topics. So performance planning is nothing but it is deciding, it is a way, it is a process that you come up with to decide what is the hardware required for your Oracle database. It is the process to decide what is the operating system to use. It is a process to require how is your network infrastructure to be, what is the bandwidth of your network to be, and not only that, you should also remember the costs of your project, because architect is not only responsible to design the Oracle database for a better performance, but parallelly he should also look at cutting down the cost of your Oracle database. It can be on the hardware side, it can be on the software side, it can be on the network side, because these are the three major components which will add cost to the project, right? Hardware is in terms of your devices, storage, RAM and CPU. Then is your software. So licensed software is nothing but your Oracle database, right? So Oracle database is licensed based on the number of CPU cores. So definitely licensing software cost should also be optimized. The next one is network cost, because network bandwidth, most of the dedicated applications or dedicated or you can call organizations will basically go with dedicated bandwidth. So each and every 1 megabyte of bandwidth will incur dollars of cost to the project. So that is also something that has to be considered. So all of them will come into performance planning. So performance planning includes architecting, decision making, and then research. Okay. Next is instance tuning. Once the Oracle database is up and running, in case if it is not performing as expected, so probably memory is not being sufficient, you have to increase the memory, or probably the number of processes has been increased because the application has grown to the next level. The number of processes has been increased. That means number of users in the application have been increased. You can take any good application like Facebook. When it was initially started, there were only 100 guys in the university, right? Then moved on to 500. Now you know what is the size of it. So as the number of users on the application increases, your database level tuning activities will also increase parallelly. Okay, that is all we call it as instance tuning. When it is instance tuning, please consider it includes both storage level tuning, process level tuning, also memory level tuning. Because if you remember in chapter number 2, we have considered or we have made a bucket saying that an instance is nothing but it's a combination of memory as well as processes. So when instance tuning comes into picture, mostly it will be on the memory side. Okay, that is nothing but your SGA tuning, system global area tuning. So deciding what should be the size of your SGA, deciding what kind of configuration you need to give in the SGA, whether you need to increase shared pool size, large pool size, etc., etc. That is what all about instance tuning will speak on. Then comes to SQL tuning. So SQL tuning is one of the very oftenly seen requirements in all of the performance tuning issues. So SQL tuning is nothing but if there is already an SQL running in the Oracle database, but if it is running very slow because of some XYZ reasons, you need to basically identify whether it is an issue with the SQL or whether it is an issue with the database or whether it is issue with IO, etc., etc. And out of which, in case if you find that SQL is a problem, if SQL can be rewritten with a better joins, better where conditions, better indexes, better statistics, better hints. So if you can come up with all these things, you can tune your instance, sorry, you can tune your Oracle SQLs so that it can perform better, because execution plan is something that makes the difference in the performance. Okay, so having said this introduction, I have discussed the similar or the same points in detail in the next topics. So one is the performance planning. As we speak about this, so as we spoke about this, these are the things that comes into my mind whenever there is a performance planning that has to be done. First one is investment options, as I told you, costs. Second one is system architecture, that means it includes OS and storage. Then it includes scalability. So that means in the next 5 years or 10 years, how big is my Oracle database going to be? Okay, so today the amount of data in the database probably is 100 MB, but by the end of 10 years, how much will be the size of my database at a, it is just a prediction value. So if you can predict, then you can architect the database based on the data that has to handle even in the 10 years. In case if you are failing to do that, your database will start deperforming as soon as your application users or usability starts increasing. So scalability is something that whenever you are planning your Oracle database architecture should be very important. And application design principles, as a DBA you should know how application works, what is the behavior of your application, so that you can have your database in sync to handle all the requests from your applications. And you should have certain testing methods in place, whether whatever you have architect is the correct or not. You should basically test them in a test environment. You have to remodel them if that is required, and if it is everything good, then you are the person who makes the decision to get into the production. And then deploying new applications whenever there is a new application coming up. Again, coming back to the first line of your performance planning is very important. Okay, so that is what we basically do in performance planning. Then tuning up the instance, as I told you, have a well-defined goals for tuning up your Oracle instance. Do not do it blindly. Okay, one major thing that I see every DBA is, if there is an issue in the database, right, directly they will go and see, okay, there is a small memory. I have seen memory allocation issue in my alert log file. As soon as I see that, let me go and increase the size of my shared pool. No, don't do those things very blindly. Monitor, analyze, define your goals, and only act upon your defined goals. While you're working on a defined problem, you might see additional problems also inside the database while you are analyzing. Do not get deviated. Okay, try to fix the goal that you have in your mind. For example, if you are working on an issue where there is a IO issue, okay, so you have to think about options what can reduce the IO. While you are working on IO, there might be memory level issues also. Don't deviate to memory level issues to fix them. Fix the IO. That means you have to fix your goal first to tune the instance, and to resolve that goal, whatever parameters or the analysis that you have to do, you have to go in that approach. Okay, so you have to allocate memory to the database architectures. That is one of the tuning instances, and you have to also have the knowledge on IO requirements. Only if you know the IO requirements, you can judge what is the amount of memory that you would need. And you have to tune the operating system also for optimal performances. So one of those, I think there is a database, there is a blog also written by me on why kernel parameters are very important to understand for every DBA, right? So in that I have clearly shown you kernel parameters are the parameters that will support the Oracle database on the server. So if you understand kernel parameters much, You can tune your operating system also to support Oracle database very good. Okay, so I have given one of the examples. See, a goal is nothing but a goal such as process 500 sale transactions per minute is a very easier job to work on. But if somebody says that make it go as fast as you can, and well, we will know when it's good enough. That means the second point is basically telling you it's a challenge given to you, saying that I'm telling you to perform 500 sales per minute is fine, but I'm telling you perform those 500 transactions as fast as possible, not just in 1 minute. Show me that it can be done in 10 seconds. Show me that it can be done in 5 seconds. Show me that all of them can be done in 1 second. That's a very big open statement. Your colleague might achieve this in 20 seconds, and another colleague might achieve this with the help of parameters and all in 10 seconds. But who will be much appreciated? The one who is configuring the Oracle database to handle it in 10 seconds will be much appreciated over 20 seconds. So your skill should be towards the goal. Okay, not just the goal is always to improve a certain area of issues. All right, so that is what you need to basically keep in mind while you are tuning up the instance. While tuning up the instance, right, this is the top to down tree that you need to follow. First, tune the design. Okay, so when it comes to the design, it is nothing but how does your Oracle database has been designed. Probably the design of your Oracle database might be a flaw. The design might be including table spaces available on different disks or on the same disks. That is one of the designs. And what is the storage type that is used by the table spaces, whether it is RAID 5, RAID 0, RAID 10, RAID 1, etc., etc. All of that design consideration is the first thing that you need to analyze. Then you just check if you can tune your application code. So application code is nothing but your SQL tuning. So most of the application code handling is nothing but your SQL tuning. See that if you can help first in addressing SQL tuning. And if that is not the case, then you will basically go with instance level tuning. Okay. And please remember guys, whenever you are tuning up your Oracle instances, tune one of the areas which will give you a potential benefit. Okay, so that means if you're working on a performance issue, okay, there might be 4 issues. 1, memory issue. 2, IO issue. 3, CPU issue. And 4, probably your SQL issue. Now, if you think that solving up CPU issue will reduce my performance problem by 90%, and all other 3 issues will only improve 10% of my performance, leave those 3 issues, catch the CPU issue, and then fix that issue. So that means you will see maximum benefit by closing up one issue. So always pick up that particular issue which is troubling the Oracle performance a lot. Because if you look at a horizontal view of the Oracle performance, there will be multiple components which are creating the issues. But out of those multiple components, it is the responsibility of DBA to analyze and pick up one of the components or 2 of the components which will give you a drastical improvement in the performance. Right? So that is very, very important skill of an Oracle DBA to recognize those components. Okay? So identify and tune probably the SQLs. You might decide SQL might be one of the one of the components that I need to pick to fix it. And you can fix waits, you can fix service times. Service times is nothing but your service refers to your listener service. So on which service the database users are connecting with, are there any bottlenecks by that specific service is what you have to pick up, and in case if there is an issue with that service, you handle it, right? So these are the tuning areas. The one important point that you need to remember is pick the component which gives you a greatest benefit and then fix it. That's the most important. And whenever your goal is met, stop tuning. Don't look into it too much, because every second there is a problem in the database, because database is designed to handle all of them. But Only when you have a drastic performance issue, try to look into it. Okay, people would call proactive performance tuning. It is very, very important and very, very good. But do not consider that in the proactive performance tuning, you need to basically skip few of those even if you find them problematic, because that is expected. So that is there are a lot of components which you might feel problematic when you look for the first time, but that is the way that Oracle database works. So it doesn't mean that Oracle database is under a performance drench. Okay, so there are multiple strategies that Oracle has developed to handle any of the performance issues. So I have given up the basic steps. One thing is you check the OS statistics and the health of the machine first. So whenever there is a database issue, probably people will start logging into the database, try check memory, try check a number of users connected. No, don't do that. I'm telling you upfront. Whenever you are dealing with the performance issue, log into the database. First, server. Check the operating system memory. Check the operating system CPU. Check the operating system processes. Check the operating system I/O. Check the operating system network usage. This is the first thing that you need to do. It might be any of the performance issue that you are handling. The first check point for every DBA is to check the operating system. Please remember this point. And that is the reason why I said that this particular chapter is pretty dry, but whatever I'm discussing now will help you a lot whenever you are handling a performance issue. Remember this. Okay, and then you have to tune from top to bottom. When I say top to bottom, it is nothing but decide whichever is the important metric that you need to handle, which gives you a potential benefit. Pick that and go to the bottom. And very similarly, tune your, first go with design part. Check if there is everything good with design. If that is fine, next go to the application coding. Just check everything is fine. If that is fine, then go to instance level. Then if instance level is everything fine, then probably the issue is not on the database. But that is a very, very rare case. Okay. Now tune the area with greatest potential benefit and then stop it when you see it. That's what I just said. Now, what are the different things that you basically need to decide whether your instance is good, whether your SQL is good, and whether your design is good, etc., etc. One of the very important things is statistics. So statistics are equivalent to the real-time information of your Oracle database. Okay. So statistics, how do I explain you the statistics? I'll take a very small example. Consider, okay, I think I often take this example in all the batches, but yeah, it is good to know with. For example, you wanted to travel on road from one location to another location, okay? And now there are multiple routes by which you can reach your destination from your current location. But out of them, you will always run some algorithm in your brain automatically to decide which route to pick. So to decide which route to pick, you basically take the help of your brain, saying that first important thing you will look into is which is the shortest path. Next important metric that you look at is in which route the traffic will be less. And the next important metric would be which route has good roads. Okay, I'm speaking about the roads in India but not in other countries. Yeah, so which route has got best roads, which route has lot of colleges and schools. So in case if there are a lot of colleges and schools, you will find a lot of traffic based on the timings. Then you will think what is the climatic conditions. Okay, so whether is it about to rain, etc. So what is that I'm trying to tell is, for a small travel that you are going to do from one location to other location, inside your brain, okay, you will run all those analytics. You will have all that information to capture. You already might be knowing few of those metrics. From the known metrics, you will come to a conclusion which route you have to pick. Okay, so all this example is well before Google Maps is there. Okay, now don't compare with the Google Maps. Google Maps will also do the same thing. It will calculate all the metrics, and out of calculation of all the metrics, it will give you the best path. That's it. Even before Google Maps, you did the same thing in your brain. Now, these metrics are called as statistics, which will help you to find out the best route between your source and the target. Very similarly, whenever you are running your Oracle database SQL statement in the instance, your Oracle would need some statistics so that it can decide how it goes and gets the data from the disk. That's it. So the statistics would include where is the data available, what is the table name, and what is the current size of the table, what are the columns, in each column what is the size of the column, and how is it distributed across all those disks. So each disk will have the memory address. So do we have memory address on in the index? So if there is an index, take the help of an index, go to those memory components, get the data. So the routes to find out where the data exactly is in the disk is what will be available in the statistics. So if the statistics are good in the database, that means your instance can go and pick the database data very, very fast. Very similarly, in the example which I have shared, if you have the complete data about from one location to other location, including traffic, including roads, including shortest distance, etc., etc., you can decide what is the best way to go with. But do you succeed every time? No. There is always possibility that you might fail. Very similarly, Oracle will also fail sometimes to find out the best path to go and read the data from the disk. That is when you will need Oracle DBS to step in to solve that problem. Okay, so this is what is all about statistics. So we call them as optimizer statistics. That is what we also have in the coming up topics, so don't worry about it. So statistics are important for the DBA to look at. One of the very, very important information is about weights. At every stage, what are the weights, how much amount of time I need to wait if I go in one route versus how much amount of time I will wait if I go take another route. So that is the reason you might see sometimes very oddly Oracle will also go and get the data even if the index is not there. Even if the index is there, it will not use index. I don't know if you have seen, if you have already worked on Oracle database, this is also possible. Even if the index on the database table is there, your database might not use index also if it feels that using index will delay. If that is what it feels, then it will avoid using index also. One such cases is full table scan. If you are not using where clause, definitely your instance will not use the index, because anyway I have to go and read the complete index objects and also the table objects, because there is no where condition. Instead, I will directly go and get the complete data by full table scan without using an index at all. Okay, and statistics might be divided into a session based, SQL based, service based, and other dimensions also. When it is other dimensions, it can be data, how the data is separated, how are the buckets, histograms, etc., etc. It depends on all of that. Okay, I have given a very small example here. I think it will be very exciting if you can just read through this example when you have some free time. 95% archive log area. This will make a lot of sense if you already have some DBA knowledge, and even if you don't have, this is like a story writing. You can basically check that. It will help you. Next important thing is sessions. Sessions is nothing but a user who is connected to the Oracle database, right? So event sessions information is also very, very important to handle DBA performance, database performance. So these are the different dynamic performance views. I hope we have covered dynamic performance views already. So these dynamic performance views will have the information about sessions. So first basic important dynamic performance view that we basically deal with every day is $session. So SID is the unique ID that is given to each and every session that is connected to the database, which has the child tables. $session stat will also have the information about the session statistics here in $session stat. And there is a session address, and again there is another child table called as SID. Okay, so that is $session event. You will have the total events, total wait time, event ID, etc., etc. about this particular $session. And same event details are also there in $event name. Event might be an action that is performed by the session. So it can be a read access, it can be write access, it can be reading table, writing table, moving up a row, all these will fall into events. So we have wait events, we have actionable events, there are a lot of event types that you can basically check out, but not at the moment because it's an advanced topic altogether. That's the reason there is a separate course called as performance tuning in my catalog. So it takes a different angle of dealing up with the performance tuning issues, right from basics to very in-depth analysis. So all this is good to know at this stage as a basic level, but you will come to know only when you act upon them. Okay. So whenever you are dealing with sessions, you will deal with all these session level dynamic performance views. I think my system might be up and running now. So what I do is I take one of these. Okay, 1 minute. I take this Control F. Why is this Facebook Hub? Let me take this. I'm sorry, this putty. Okay, so let me connect to this putty, which is this. Alright, so this is the server that we have been using, and first thing is set up the environment variables, right? Then bring up the listener ctl start. Then we will have to bring up the database as well. So let us do that also. SQL plus /SLTBA and then start it up. And OraDB is non-CDB database, just to remind you guys. So let the database starts up. We will just look at these sessions, and I will also show you how do you relate with $V event or $V session event. I'll take these two things and I'll join these two dynamic performance views, and I'll give you some results that will help you or excite you a bit, because that is what is most important whenever you are dealing with performance issues. So all your SQL skills that you have learned in the first part of this course will be very useful here, because joins will come into the picture now, right? This is one table, though it is called as dynamic performance view, it is one table. You have details of sessions here, you have total waits, total timeouts, all of them is here. So you have to join these two tables based on SID, and out of that you can again join a table with event ID and statistics ID also. So you can do all of that stuff now. So let us check. So first of all, select SID from $V session, where username is sys, because I connected as sys user, right? So there are these many sys connections, but I need one which I just connected. So what I'll do, SID comma username comma, I think there is a column called as describe $V session. So there is something called mm, process terminal program type. Okay, select SID comma program comma type comma username comma, then I would go with one thing is, where is it, terminal from $V session, where username is sys. Now let's check this. Now if you see all of them, you have only one SID, which is SQL Plus, connected with SQL Plus, right? So this is the session SID that I am related to. So my SID given by the database is 1. Alright. So this is my SID. Now let's see. Let me join. Select if there are any wait events. Select SID comma. So according to this, we have total waits, total underscore waits comma, then what else we can give, total waits, time weighted from, I'm only combining, two sessions now, from v dollar session, comma, a, comma, v dollar, what is this, session event, session underscore event, where a dot sid is equals to b dot sid, and a dot sid is equals to 1. Okay, so this is ambiguous, that is known, because SID is available on both of them. So let me make it disambiguous. So now if you see, these many waits have happened so far. Since the time we have connected, 28 waits in the background happened for 4 seconds. Okay, I think time weighted will be in microseconds. How do I do? There are these columns, right? Whether the values are in seconds, microseconds, etc. How do I basically take the assistance from? So I basically take this dynamic performance view. I go to my Google, or it is not Google exactly. I'll take my Oracle documentation helps. So Oracle. So just take this Oracle 12c. This is one of the methods I follow. Probably you can also check. So I only go with docs.oracle.com links on $V session event, and now you can clearly see total weighted, it is in 100th of a second. It is not in microseconds, it is not in seconds, because it is very hard for us to remember, right, whether which column is in what units. So I take the help like this whenever I'm working on it. So this is in 100th of a second. So whatever it is 0.004, 0.13 seconds, 0.13 seconds, and 1.36 seconds have been weighted. So this is the total time that is weighted. In case if I want to sum them, if I want to see what is the total time spent, weighted time spent by my session so far, what I'll do is I'll do a group by, as simple as that, comma, sum of total underscore weighted so far. Okay, and then what I do is from this, and then what I'll do is group by a dot sid, right? Total underscore weighted, time underscore weighted, and this. Now if you see, there is total of 323.45 seconds weighted. Okay, but is it really true? So if it is 320 seconds, that means it is 5 minutes. So more than 5 minutes, right? Did we actually log into the database for 5 minutes? No. It is very much, very less than that or equals to that. So do you think that this total time weighted is something which is actionable? So that is what you need to basically take with, because time weighted can also be idle time. Okay, you need to basically consider waits which are weights just because of an event inside the database. So that is the reason what we will do is we will again take another component called come back to this, what is the event on which he is waiting. Okay, so I'll show you. See, these are some important exciting things actually. B dot event. So that's the reason I'm spending some time, comma, but you need to spend some good time to understand all of them. So now if you see, for DB file sequential read, there is a lot of time weighted out of the complete things. Okay, so there is something called checkpoint, control file, parallel write. DB file sequential read is something that is actionable, and DB file wait. So DB file read is not considered as wait. So now you have to consider waits only if there is a wait in the particular C. This is a wait clause. For the events in the wait clause, it has only waited for 1.49 seconds. So it is not a problem. Okay, so SQL net doesn't, DB file sequential read is fine. So latch control, see, there is total of, this is the idle time actually. So that is the reason you should not consider this time at all. If you consider this time, idle time is also considered as wait time. This is how you need to basically debug what is the time. But there are scripts also directly which you can execute and then give you the problematic sessions, but I'm trying to show you the basics. So if you know the basics, how to act upon, you can do from the scratch and you can be a better DBA. That is my approach. So you have to understand what is the concrete first to build up your building. Okay, so that is what I mean. So these combinations will help you a lot. Probably it would be boring in case if I go in detail of all of these dynamic performance views, what you get next and what you get next, but the approach should also be the same. Okay, that is what I wanted you guys to remember. And you can get CPU, for a session, how much amount of CPU is used, how much amount of PJ has been used, how much logical reads, physical reads are happened. You have known, right? See here, just like this, DB file sequential read, that is nothing but the logical read, correct? So you will see how much amount of time has been spent for the log file, for the data files, and yeah, parallel write, read and write operations. You can also see how much amount of time spent. So all of them you can basically check. The same thing, weights, I just wanted to conclude here. We have already dealt with weights just now. So the weight event classes can be all of these types. So if you wanted to know the weight event classes, right, the dynamic performance view is where is the event class? In event name, event, 1 minute, stat name is class. Let me describe v dollar session underscore event. If you see event ID, event name, event, yeah, weight class. Now I'll take the same query that we used. I'm sorry. The same query that we used. What is it? So in which I basically include b dot weight class also. Okay. So now let us see this. Comma b dot weight class. I'm sorry, event. See, these are the events, system IO, configuration, user IO. This is for the application. For user IO, there is 1432 waits. So this is idle. See, this is the reason I was telling, directly looking at this event, I was telling that this is the idle time. So how can you basically figure out? Wait class will be idle. So if the wait class is idle, do not consider that as wait time. You can skip all the columns which are having wait class as idle. So even without looking at wait class, I was telling you this is the idle time. It is from the experience because I know from the messages also, but that is what you need to basically look for. So Oracle is limited with all that it does, but it is complex when you wanted to combine all of them. So if you are very clear of how complexity is, how they are joining the tables to get you the details, you will be very much clear on handling the performance problems. That is what I wanted to know you guys pretty much. So that's it for this session. So I stop it here in the weights, though it is an introduction. In the next part of this chapter, we are going to deal with memory management, and let me check. Yeah, this is also in memory management. And then we are going to deal with SQL tuning a bit, optimizer a bit. That will give you much more things to know. Optimizer statistics is another point. We are again going to come to the same dynamic performance views on the statistics part, and then we take some of the examples, and then yeah, tuning advisors is one of the important thing that you need to know. So this is what I have pretty much to cover in the next discussion, because it would take another 45 minutes. So it's better I break it up here, and then I'll start another session on this, the rest of the 12th chapter topics. So if you have any questions at this moment, please feel free to ask now on whatever topics we discussed. Okay. Hope there are.
Yeah, I'm fine. It's muted now, so
Yeah. So I hope there are no questions from the team now. So closing the session here. We'll meet in the next.